Hello everyone, this is an introduction to Big Data Architecture. I am Devika Singh, Assistant Professor, School of Computer Applications, BVD University. Hi everyone, this is an introduction to Big Data Architecture video. We will use a very generic reference architecture and talk about various layers in details. So let's get started. First, we will discuss the different types of sources that can send data. The real power of big data is to ingest tons of data from a variety of manual sources. The data can be classified into structured, semi-structured, and unstructured data. So, the structured sources can be our traditional systems like data warehouse, data mart, OLTP, and ODS, containing an organizational data. Further, we can be CRM or ERP systems, and finally exposed APIs. Now, what exactly falls under semi-structured and unstructured data? That can be debatable. Organizations have their own classification mechanism, so we will be using our best judgment. Now, so what can constitute a semi-structured data? Well, NoSQL databases is to begin with. That's what makes it different from structured data to begin with. Next, log files can be semi-structured data since there is some elements of structured or patterns induced while logging from the code. Next, an email can be another good example since it has headers, subjects, to, CC, BCC, fields in a structured format and email body in unstructured format. Next, organizations uses a lot of spreadsheets. So a spreadsheet containing data without any accompanying schema or definition can be classified as a semi-structured data. And finally, HTML, CSV, JSON, and XML files are all examples of semi-structured data. Now moving on to unstructured data, it gets interesting here. Multimedia groups like images, audio, video can be a very first example. Social media data streams can be your next. Another good example of this category is messaging data like SMS, WhatsApp, chats. Now taking this a level further to explore full potential of big data, we can have geo or maps data, sensor data, and data coming from smart devices like smartwatches, etc. And finally, websites, web pages, online articles, texts, and medias are all examples of unstructured data. Now that we have discussed sources, let's focus on the big data system side of things that are covering different layers which are there. So how will we structure this conversation? We'll cover this conversation in three parts. We'll first discuss layers, then its components, and finally the possible data flows. So let's first understand the different layers that are there in a big data architecture. There can be data ingestion layer, data storage layer, analytics layer or so known as servicing layers, or simply a service layer. Then data consumption layer, and then finally big data governance layer. Please note that there are multiple big data systems with or without with some of these layers. I have here tried to generalize few of the layers. Since this is a generic reference architecture, so focus is on high level and learnings. Now, two things to note here. First, you must have seen a dedicated processing layer shown in some big data architecture diagrams. Processing is basically moving data from one layer to another. Hence, the processing layers, namely batch and real time, would be overarching these layers that you see. So I will be showing these type of processing in the later part of my videos. Second, I've combined analytics and servicing layers by showing analytical processing and its pre-computed outputs into one. Also, all on the fly or enumerative activities we will show with the help of arrows. So now coming to a second part of three parts conversation, let's discuss the components of these layers, starting with the ingestion layer. There can be a batch component and there can be a real-time or a stream component, which is the two different shades of a big data architecture. Now coming to data storage layer, there can be traditional relational databases to store structured data and yes, at a time semi-structured data. Then There can be one of many types of NoSQL databases to store structured, semi-structured and unstructured data. And finally, we can have a Hadoop distributed file systems, which is a fault-tolerant distributed system. Next one is the analytics or serving layer. This is the layer where models and engines run and provide outputs to be utilized by the consumption layer, typically on demand. It can has statistical and AI models. It can has recommendation engines like those Amazon product recommendation or YouTube video recommendations. It can have a knowledge graph, which is widely used for link analysis and social media analysis. And finally, output of these models and engines, which are usually pre-computed, used for user queries. Now, talking about data consumption layer, it can have a range of things that an end user or a target systems can use. Most likely these are DI dashboards, reporting, data visualization, insights generation, real-time alerting, real-time searching, and query capabilities, and finally downstream systems, which would be typically at an enterprise level. Finally, we have big data governance layer, which is used as an umbrella term for the data management activities like data auditing, data security, data quality controls, data catalog, data management, and etc. Please note that a big data system has high chances to fail if big data governance is not done right. Finally, the third part of the conversation is the most interesting, that is possible data flows. Okay, broadly there could be two flows. These flows are batch and real time. Let's start with the batch side of the things. A batch is scheduled and hence periodic, and it should write towards dedicated storage before any analytical activities can happen. It's used for cases where historic data and significance of the data where is to be maintained. For a better flow, the data distance sent to be is scheduled very typically and then processed and then finally send it to the downstream. For full flow consumption layer, analytics layer uh, requires the data storage and processes the full-fledged layer. Now let's talk about the real-time or stream side, which makes this a big data architecture, full-fledged. The first flow is here, which is scattered into a real-time stream and memories. So typically this makes the use of capability and hosted an analytical layer, but can function with using those capabilities for a limited number of use cases where speed is everything. A good example of such use case where analytical layer capability is not required is real-time alerting. What we just discussed is real-time processing without a serving layer, but there can be also a dedicated serving layer. Now let's talk data storage for real-time processing. Even though the data is picked up from online or external sources and cater to real quit, if there is a need or requirement, the data can be stored parallel at the parallel storage. So now that we have covered the three topics of our conversation, let's discuss the final topic for today, which is overarching process. What you see highlighted is called batch processing. Now there can be two variants of real-time or stream processing. The first variant, as highlighted, is a dedicated serving layer. The second variant are shown, that would be the one without a dedicated serving layer. So that's all in this video. If you would like to see more topics covered on big data, do let me know in the comment section. Thank you.